Physics Bites,
Physics Bites,
a science podcast in English by the students of Notre Dame d'Ascension.
Hello and welcome to Physics Bites, the English language physics podcast of the students of Notre Dame d'Ascension here in Paris. We are back with a new episode in our New Energies project with our junior level students. I have three new experts who are going to talk to us about geothermal energy today. So I'm going to let themselves introduce themselves and then we'll get the show on the road. Who wants to go first?
Okay, so I'm Lina and it's my second year at DNL courses.
Right, you were in my class last year in grade 10 and you decided to continue, thankfully.
Exactly.
And then we have a new student this year, two new students. So let's begin with Maroussia.
So hi, it's Maroussia and I'm new to this class this year.
Right, you weren't in the class last year.
No.
You decided to join us this year. And your sister used to be in our class, Suzanne, who was
Yes, she was.
who did a couple of these podcasts before when she was in her junior and senior years. And then our final new expert.
Hi, my name is Salomé, and it's also my first year at DNL courses.
Right, and we have Salomé, who's having slightly sound issues, but I think it's going to be fine. All right, so let's get the show on the road. Geothermal energy. It's one of the forms of energy that I think most of the class knew the least about, and so it was a topic that taught everybody a lot of new things. So I'll let you guys get started. Maybe Lina can begin by giving us a very short summary of what geothermal energy is all about, where it's coming from, and then we'll get more into details about what are the pros and cons of this form of energy, what are the limitations of it, and then finally we'll talk about what the future prospects are. So, Lina, do you want to start us off?
Yes. Okay, so geothermal energy is the energy of the heat inside the earth. So we use the heat of the earth to create energy, to produce electricity, and to heat buildings. And we know that with 0.1% of the planet's heat content, we could supply 1 million year needs in energy needs for the future.
So basically, there's a lot of energy inside the earth, is what you're telling
exactly.
us.
So
maybe you can tell us where this energy is coming from. Why is there so much energy and heat? What the sources of it are, the origins of it?
Because we know that the interior of the Earth, the temperature of the interior of the Earth can reach more than 5,000 degrees. So the heat comes from the heat from when the planet was formed. So this is the first reason. And the second reason is the heat from the decay of radioactive elements. So when the planet was formed, it was with the process of accretion. Mm-hmm. So this is the process where small particles of dust, of gas, or ice are sticked together and are collected. So there were big masses that were attracted together, and they formed bigger masses until reaching the size of our planets.
And we're talking about maybe 4 billion years ago or something like that?
Yeah, exactly.
It's a long, long time ago.
Yeah, really. And so this process produced a lot of heat. And actually it represents more than 10% of the total heat inside the Earth. And the second reason is the heat from the decay of radioactive elements. So when you have isotopes, with it's produced at the crust and at the mantle of the Earth, the radioactive. So there are a lot of radioactive elements. Mm-hmm. And so this process is going to create a lot of heat, and it represents 90% of the heat inside the Earth.
Right, and this is quite reliable in the sense that when we talk about renewable energies, many of the forms of renewable energy that we use are what we call intermittent, in that we can't count on having them present all the time because of like climate reasons. This, if we can access it, would be constant, or is it sort of intermittent as well?
No, it's really constant, so we know that it is going to stay as is it actually.
Okay, so that's always good. So potentially geothermal energy could be used as a base load energy, which is what we like. Okay. How long have we been using geothermal energy as a source? Is it a very like a new thing in 20th century?
No. So first the Romans use it for
Okay.
the hot springs, like, you know, the big bath, and it was transformed, and we've really started to use it in, I think it was in the 20 decades,
Century.
Century, sorry, yeah.
Yeah.
And it
Okay.
was an Italian that used it first.
Right. So I guess in an indirect way, anytime we've used hot water sources to do anything, we're using geothermal energy, but geothermal energy in the sense that we talk about it in the modern day is more of a recent 20th century development.
Yeah, exactly.
Okay. So maybe we can move on to something more specific about geothermal energy. You talked about a geothermal gradient, and then we'll talk about the different kinds of plants. What do we mean by geothermal gradient?
So the geothermal gradient is the temperature of the crust, which depends on the different area of the world. So in some regions, for example, the temperatures increase by 100 degrees Celsius per 100 meters of depth, but it's not really common. For example, in Ile-de-France, it increases really slower. It's about 3 degrees Celsius per 100 meters, and in areas with mountains such as Auvergne, it's about 8 to 10 degrees Celsius per 100 meters. So this is really important to have to know a little bit about how we can use it and where we can use geothermal energy.
Right, which is, I guess, as we'll talk about later, one of the limitations of this type of energy.
Exactly.
Okay. So let's get straight to how we can exploit this sort of energy. Let's assume we're in a place where we can access it. What are the different ways of exploiting geothermal energy to produce electricity, heating, whatever the different kinds of things are that you guys researched?
So there are three main types of power plants that are used it depends on the heat of the earth. So for example, there are dry steam power plants. So they don't need a really high temperature. There's a lot of temperature, like 300 degrees, which is really important, and you have to drill a lot, so it's not really easy to use. And so it is going to use the steam directly, and this is why we have to use it in really specific areas. Then you have the flash steam power plants, which requires like 150 degrees. And it's easy to use, but it is going to be less efficient. Mm-hmm. And then there is a binary cycle that can be used almost everywhere, but is not gonna be really efficient, because you're just gonna use the water inside the earth, which is not steam, and it's gonna
so just hot water as opposed to hot steam.
Yeah.
We know that hot water can never be higher than 100 degrees, but steam can go above 100 degrees and have more energy.
Yeah, exactly. And it depends on the boiling point, and with the pressure, the boiling point just increases by the depth. So it's with a binary cycle, you just have to use hot water, but it's not going to really be efficient.
Right, but the advantage of this binary cycle is that, what is the advantage actually?
You can install it almost everywhere, but this is the advantage.
Okay. And then once we have this hot water or hot steam, we produce electricity how?
Sorry, it cuts.
I'm saying once we do have the hot water or the hot steam, how do we produce the electricity from it?
Yeah, so it is gonna go into turbines, and the turbines is gonna turn and go into activate a generator, and this generator is gonna transform the kinetic energy into electricity.
Right, so this is exactly how we produce electricity in almost every other case, whether it's from wind or thermal power plants. Once we have that hot steam or some rotation and movement, we just hook it up to an alternator, a dynamo, and we produce electricity from it. Okay, I think you mentioned also two different types of what we call dry steam power plants and flash steam power plants. What is the main difference between those types?
Okay, so the main difference is dry steam use only steam. So the steam is gonna go with the pressure into turbine, make a turbine turn, as I said. And the flash steam poured is just gonna go to a flash tank. So this is liquid water, which is gonna go in the flash tank. And this flash tank, is gonna transform liquid water into steam to make the turbine turn in.
Okay, and is there an advantage to one to the other?
So, yeah, the flash steam requires a lower temperature because it's liquid water.
Okay. I'm curious, and I think any of the three can answer the question. So what you're talking about here are basically what we call geothermal plants, which means geothermal energy being used in like big power plants to produce electricity. Are there other uses of geothermal energy that is not necessarily directly producing electricity? Did you guys come across that at all in your research, where we just use the heat from the earth to do something, not necessarily produce electricity? It could be at a more small scale. Lina?
Yes. For example, we can use heat for heat the water inside the house.
Right.
So, for example, the more particular people, just one people can install heat pumps, for example, to heat their house and not necessarily using electricity.
Right, heat pumps, which have been quite in the news the last, I guess, 5 years or so as one of the main sources of heating, are basically using geothermal energy, but in a sort of a individual scale, right? And how do you have an idea how we can use geothermal energy on such a small scale? So how does a heat pump work, basically?
It's the same. It's just like hot water that is gonna be pushed up with the pressure and with a heat pump, and it's gonna.
Okay. So there's two different kinds. One is either we take water in our normal home water circuit and we make it go through the ground, and it captures the heat from the ground, and it sort of heats up the water naturally, and we use it. The other would be to actually take hot water from the ground. I think then you would have to go deeper into the ground and then sort of either spread it out in a network or individual houses. Yes. Is that the idea? Okay. So maybe we can move on to just doing a pro and con list of what is good about geothermal energy, what is less good about it, what the limitations are. And I think, Salomé, you were the one who were sort of more focused on doing a study of geothermal energy. Maybe you want to give us a summary, a rundown of what you came up with and what you told us in class.
Yes, so I will talk mainly about the advantages of geothermal energy, because there are many. And I will also explain a few small disadvantages, but only at the end, because the benefits are much more important.
Okay.
So at first, geothermal energy is renewable, because this energy will never run out. So as long as the Earth exists, we will have geothermal heat. And scientists also say that we have used only 1% of the Earth's geothermal potential. So there is a lot more to use in the future.
Okay.
And this energy is also always available.
Right.
So it's not affected by the weather or the season or the time. It's a constant and stable energy source.
Right.
So geothermal, for example.
And this is very important, because if we're going to use electricity as we want to produce electricity in a very constant, reliable way, we need sources of energy that are available constantly and are not just part of the day or part of the season or something like that. So this is very important if we can actually do this.
Yes. Exactly.
Okay. What else? You talked about the carbon footprint and the land footprint of geothermal. Can you give us a bit of details about what you mean by that?
Yes. So if we talk about the land footprint, So geothermal power plants don't need large areas like wind farms or solar panels. This is good for the environment because we don't need to destroy forests or natural areas. For example, to produce 1 gigawatt of electricity, a geothermal plant needs 400 meters square, and a solar plant needs 3,200 meters.
Okay, go on.
And installing a geothermal system, geothermal energy is very clean because it produces very little pollution compared to fossil fuels like coal or oil, because deep underground reservoirs contain hot water, steam, and some dissolved gases like CO2 or CH4. And when we dig, these gases can be released at the surface. So to compare a coal power plant and the geothermal power plant, so coal power plants emit about 820 grams of CO2 per kilowatt, and geothermal plants emit only about 38 grams of CO2. So that's 20 times less CO2 for geothermal plants.
Okay. So this, I think this, we can sort of, I guess, talk about this question of the carbon footprint of geothermal energy, because I think there's a lot of debate around that. In that, so while it is functioning, we're not actually burning anything, so we're not emitting any carbon. But to get to that energy, we do need to spend a lot of energy. We do need to sort of dig into the ground, right? And that is one disadvantage, I think, of this form of energy. Can you go into maybe a bit of detail about that, or any of the other ones?
Yeah, so I'm not sure if I understand, but when you drill into the in the crust, you have like pocket of gas that can emit some gas,
right,
and which
right.
can be really toxic and not good for the environment. So this is the main disadvantages.
Right, in terms of the carbon emissions, because if it is near somewhere where, for example, we have oil reserves or gas reserves, the fact of drilling into the ground is going to open up a pathway, and these are gases which are very bad in terms of the heat capturing that they do in the atmosphere. Okay. We have one question also from your classmates. Are there any other dangers associated to drilling? Because we've heard a lot about that.
Yeah, there are some accidental risks about this. For example, you have some risk of earthquakes,
right,
which are induced, so creating by the humans, because the drilling process just provoke instability on the fault lines, so in the tectonic plates, and so it can provoke some earthquakes. For example, in California, there was a big geothermal power plants that were installed, and it creates more than 4,000 earthquakes in less than 1 year, which is enormous. But
right.
It was like a magnitude of 1, so this is not really important, but it
right.
can
It's
cause
not even something
instability.
that we would feel in our day-to-day lives, but I think the problem is that it can contribute to destabilizing in regions which are already unstable. Okay.
Yeah, and in South Korea there was a big earthquake too that causes the gate.
Okay. So while we're on some of these negative aspects of geothermal energy, does somebody else want to maybe go into a bit more detail about that? Either Maroussia or Salomé, we can do maybe a little short list of some of the other disadvantages of geothermal energy, whether it's the production, whether it's getting to the digging part, or anything.
Yes.
Salomé?
So geothermal power plants. One of the disadvantages of geothermal energy is that geothermal power plants can't be built anywhere. So the geothermal reservoirs are above 100 degrees are usually necessary
Okay.
for large geothermal power plants, and these reservoirs are only found in specific locations, usually near tectonic plate boundaries or hotspots. And also, these power plants are expensive because geothermal energy is an expensive resource to exploit.
Why is that? What is the main reason for the high cost? Do you know?
Yes, because drilling into the earth is expensive.
Yeah, it's very highly technical. It's very expensive gear. It takes specific materials. So the act of drilling, the deeper you go, the more costly it can become. It can become very, very costly. You told us building deep earth or deep digging sort of power plants to get to that energy. Where in the world, I don't know who wants to answer this question, where in the world are the regions which are most reliable and most exploitable when it comes to geothermal energy? Are there countries which use geothermal energy as their main source of energy already?
Okay, so we know that there's Iceland, which used a lot of geothermal energy,
Right.
but Indonesia have a big potential too. But because they are located, it's located on a tectonic plate, but they can't use it because it's a political point of view, but it's a really slow energy. It's not efficient really quickly. And there's another problem, is it that there are some areas on Indonesia that are sacred, like because of their beliefs, they can't
like
drill.
sacred lands, I guess,
Yeah.
right? Yeah.
Yeah. So this is the main problem in Indonesia, and in Iceland it's really important type of energy.
Right, I think Iceland is something like more than 3/4 of their energy is geothermal.
Yeah. 30% of.
Basically, regions which are most exploitable are regions which have already a fair amount of volcanic activity, I suppose.
Yeah, exactly.
Because I guess volcanic activity is regions where the Earth's crust is the thinnest, and there's ways for that energy to escape. So that's the places which are easier to use. Do we have any geothermal in France?
Yes, in the Paris basin,
Right.
there is a huge hot water aquifer underground. So we use a lot of geothermal energy.
Right. I guess we can also make the association between regions where we have a lot of like mineral water and mineral baths, hot water baths, excuse me. So we have a fair bit of that around what you call the Paris Basin. Also a lot of that in Italy, I suppose. Okay. Do you know what percentage of our energy in France comes from geothermal?
Yes. Okay. Yeah, in France, it represents 3% of renewable energies, which represent 15%. So
right,
this is
so it's like 3% of 15%, which is basically nothing.
Yeah.
Okay. But I suppose in France we have nuclear, which is which accounts for more than a half, close to 3/4 of our energy. So we're doing fine in terms of that non-decarbonized energies. Okay. Maybe we can move on to the final part, what the future prospects are for this geothermal energy. I know, Maroussia, you talked a fair bit about that. Do you want to maybe go into just a short summary of the different ideas that exist, the different prospects and all that, and then we'll see if we have a couple of questions left. Go ahead.
So, like, people are trying to use geothermal energy with the water temperatures that are becoming more and more less and less high. So, for example, in Alaska, they used geothermal energy with the water at 70 degrees. So it's a first. So before we were using water at temperatures higher than the boiling point, which is 100 degrees. So it was the first time that we did that. We are also trying to make advancement with the wastewater. So, for example, we did some advancement. Like for example, we are using the ion exchange principle. So, like it's a ion. They relies on the use of ion exchange resins, which are solid materials capable of capturing certain dissolved ions in water and then replacing them with other. So there is two types of resin, the cationic resins. So they exchange positive ions such as Ca2 plus or Fe2 plus. But there's also anionic resins that are exchanging negative ions. So this process is very important because during the process of geothermal energy, a lot of wastewater are made, and we can't release them in the nature. Then I can talk about a new type of drilling. So it's called the millimeter wave drilling. So we use electromagnetic waves that are. Yes.
No, I was going to ask you a question about the treating of the water. The reason you're saying the water is contaminated because of drilling is because we put stuff in there to make that sort of drilling and the fracking more easy. Is that the reason for it?
Yes, it's the reason. Because so we just trade them with ions that are not bad.
Okay. And these sort of mineral ions are present because that's present in most water that comes from underground.
Yes.
Okay. You talked about also different techniques for drilling, right? You talked about insulating materials that we use. You talked about, I think, some other things. Do you want to just give us a very short idea of what some of the new drilling techniques might be?
So the new techniques are we use electromagnetic waves. So we generate them, and like we are transmitted them to the rock. They are guided through an optical fiber, and then we heat. When the waves hit the rock, we heat it to the temperature of several thousand of degrees, so the rock melts and we can do it very.
So instead of having to do mechanical drilling, we're usually sort of like making so the rocks become unstable with electromagnetic waves. Is that it?
Yes. Yes, that's
okay. You talked also about some ideas for hybrid power plants.
Oh, yes.
What is that all about?
So we have the idea of coupling geothermal energy with other renewable energy. For example, solar energy. So it can be very interesting.
Right, so the idea would be two forms of energy that complement each other to make both of them more efficient.
Yeah, that's it. Because, for example, the solar energy can't be used at any time because it depends of the weather. So if we use it with the geothermal energy, it become more exploitable.
Right. I think this is one of the things that some of your classmates also brought up, the fact of combining and making hybrid forms of energy tends to have a positive effect on both that are involved.
Yes.
Okay. You also talked about cogeneration, something linked to heating and cooling of buildings in the future using geothermal.
Yes. So because people are asking if geothermal energy is going to be the future solution of heating and cooling buildings. So currently we know that heating buildings for 1 year consume 16 tons of CO2. And there's company, for example, Celsius Energy, which create a project that would reduce the emission by 90% and also the cost by 50%. So the installation will be directly under the buildings.
Right.
And we not go through power plants.
Right. I think this is one of those things that is going to be quite useful and revolutionary. The idea of using geothermal energy for heating and cooling of buildings, heat pumps, because you don't need to go that deep, because you don't need high temperature. You just need enough basic sort of source of energy that's accessible, and it would be completely decarbonized. And it could be, I think there's a lot of insistence from a lot of our political authorities to try and go to there. So we'll have to wait and see how that develops and goes on. Okay.
Yes.
So I think we've gone through most of the stuff that you talked about. Is there anything that you guys maybe researched that we didn't get a chance to go over that you want to bring up right now? I guess that's it.
Yeah, I think so.
Okay. So we'll maybe finish off our interview the way we do with most interviews. I'm going to ask you guys to sort of each of you tell me about your experience doing your research, if there was anything you found that you had no idea about, and what your sort of general opinion is of geothermal energy. Do you think that it is a useful sort of solution to the energy problem and the energy crisis and climate change, or is it too specific and limited in terms of regions and cost, and just your general opinion? So I'm going to start with Salomé.
So why I enjoyed working on this presentation as a student. So at first I learned a lot of new things because I didn't know much about geothermal energy before. But now I really understand how it works and why it matters. And it's a topic that really surprised me because it's a powerful, clean, and useful in many different ways energy.
Okay.
And I like seeing how geology, physics, and environment come together to solve real world problems.
Right. So this is one of those applications of physics, I guess, and geophysics specifically, that are maybe not evident, but can be of very, very high importance for us in the years to come. Lina, what was your experience with this topic?
Yes, so I found it really interesting, and I didn't know about a lot about geothermal energy. This is not something really famous, like anyone know it, and but I was really curious because it could really be the future of energy, because even if it's not really efficient and there are some problems of environmental problems, and it could really, there's a lot of advantages, and I was really curious to know about the politics point of view of all of this. So I made some researches about it, and I found that politics are not really for this energy.
Are you speaking specifically of French politicians or in the world?
No, not French, because French don't really need that. But
right.
I've searched for the USA, for example, and I found that at the beginning, I think the old government didn't really want it, but actually they made some researches and they have financed some researches about geothermal energies, and really. It was like in 2025, so it is going to be, I think, a main energy in the future.
Okay. So you are more optimistic about American politics and geothermal energy than most people, I guess. All right. And maybe we can finish off with Maroussia. What was your experience like doing your research and presentation on this topic?
Yes. So I was really surprised to learn that some countries like Iceland and the Philippines used a lot of geothermal energy, while in France it only represents a small part of our energy mix.
Right, very small
But
part.
I also found that like France has a lot of potential for developing geothermal heating. For example, in Île-de-France.
Okay.
And,
So there's some hope for
yes.
geothermal in France. It's just that I guess because we haven't needed it that much, we haven't really
Yes.
developed it too much.
Yes, but I think it could play a big
Role.
part in the fight with the climate change.
Okay. Well, it's always nice to finish off on a positive note like that. Okay, so thank you very much to all three of you guys, Lina, Salomé, and Maroussia, for the information you gave us about geothermal energy. It was very interesting, and hopefully you will continue and advocate in the future for geothermal in France and in Europe. Thank you very much, guys.
Thank you.
Thank you.
So, that is Physics Bites for this week. We hope that you enjoyed this episode, and we would love to hear what you thought about the topic in the comments section. If you did enjoy the show, then subscribe to our podcast, share it with your friends, and be sure to leave us a 5-star rating on whatever platform you're listening on. And more important than all of that, come back soon for a new episode.